So good morning, everybody. So we're going to talk about the power rule here, and you can see a statement of the power rule up above. The power rule is used whenever you're taking the derivative of a power function, and a power function is specifically a variable raised to a number power. So if you have a variable raised to a number power, that's what this says, and it's a real number, then the derivative of that is found by bringing the number down as a multiplier in front, and then reducing the power by 1. So the derivative of x cubed, for instance, would be bring the power down in front, so 3, and reduce the power by 1, 3x squared. Now we're going to do some problems here involving the power rule. First of all, basic problems, and then on the next couple of slides, problems from the AP Classroom, which require a couple of other ideas. So the first thing is this green problem. Notice how we have all these terms that are being added together and subtracted. This one, this one, this one, this one. And from the PDF that you saw earlier in the assignment, you can take the derivative of those separately from the 7 difference rule. So I can take the derivative of x cubed and 5x squared and negative 3x and 2 all separately. So the derivative of x cubed would be 3x squared. It's bringing down the power, reducing the power by 1. 5x squared, I bring the 2 down as a multiplier. By the way, notice there's a 5 sitting there. The constant multiple rule kicks in here. So if there was a 5 sitting there, the derivative of that is 5, the same constant, times the derivative of the function itself. So bring down the 2, reduce the power by 1. Negative 3x would be negative 3 times the derivative of x. That would be bringing down the 1, reducing the power by 1. And then the 2 at the end, that was like 2 times x to the 0. And I'm showing a lot more work than I would normally here. So bring down the power, reduce the power by 1. So my derivative here basically is, whoops, math. My derivative here is 3x squared plus 10x plus 3, and then this goes away. Now, on the yellow problem. When I'm doing this yellow problem, it's a little bit more complicated, but all of these are power functions. We just have to recognize them as such. So the cube root of x squared could be rewritten as x to the 2/3 power. 6 over x cubed could be written as 6 times x to the negative 3rd, and then plus 5. And now I can take the derivative with the power rule. Bring the 2/3 down, reduce the power by 1, bring the negative 3 down, reduce the power by 1, and then that constant, derivative of a constant, that was one of the rules we looked at in the last one, I could have even used it on that, is 0. Now, at the end of this, I'm going to rewrite it as it appeared first. I don't have to, but on a multiple choice part, it's likely to be written in this form. Now, the red problem. This time I want to find a tangent line. Now remember before, when we did a tangent line, we needed a point and a slope. We still need a point and a slope. To get a point, I'm going to plug 1 into the function. And when I do that, let's see, I'll get 1 minus 6 plus 5. So I think that's 0. But remember before, when we did the slope, we had to go through either the h definition or the a definition to find it. We don't need to do that this time. Instead, we're going to find the derivative using the power rule, constant multiple rule, and sum and difference rule. Now let's see, that would be 3x squared minus 12x plus 5. And then, because this is a function that when you put an input in x, it outputs a slope, I'm just going to plug 1 in. And that will give me the slope at 1. And I believe that is negative 4. So that means my point is 1, 0, my slope is negative 4. So I can write this in point slope form, or if I wanted to, I could write it in another form, whatever floats your boat. But that's the slope of my tangent line. Sorry, that is my tangent line. Now, let's look at a couple of AP-style problems because they're a little more complicated, but not too much. So the first one is problem number 1. Oops, sorry. Problem number 1 from the AP Classroom assignment I gave you. So anytime you see a limit that has an h approaching 0 in it and an h on the bottom, I want you to immediately think h definition. And that is that. Now you may look at that and go, oh no, we just learned the power rule. Why in the world would I want to remember this? Hold your horses. There's a good reason for this, and this is actually easier than it looks. So you see here, I've got a limit as h approaches 0, I've got an h, I've got something that has a number plus h in it right here. That corresponds in the definition to this. So this tells you two pieces of information. Number one, what's the function of which I'm finding the derivative? So what am I doing to 8 plus h? Well, I'm raising it to the 1/3. So the function of which I'm taking the derivative is x to the 1/3 power. And then it tells you at what value we're finding the slope of the tangent line. You see how there's an 8 sitting there? So that means my value of 8, my x in this case, is 8. So I'm going to write a instead, just to kind of like indicate that's a specific value. Now, notice this part over here, minus 2, that corresponds to f of x. So I could check to make sure I've made the right choices by finding 8 to the 1/3 power. That's the cube root of 8, which is 2, and that should correspond to what's there. And it does, so we're good. So you're like, okay, so why? How do I do the problem then? Well, this whole thing is asking for the derivative of this function at this number. So then, instead of going through all this process of trying to like simplify that limit, instead, what I'm going to do is take the derivative using the power rule and plug in 8. Now, a negative 2/3 power means on the bottom, it's going to be a cube root of 8 squared. Cube root of 8 is 2, so this is going to be 1/3 times 2 squared, which is 1/12. You'll see some more problems like this where you have to recognize the function and the value at which you're finding the derivative from the h definition. And that's how this really shows up on multiple choice parts on the AP exam. So let's look at one more problem. And this one has to do with differentiability. So remember, differentiability means that the function is continuous at a point and the slopes go to the same number from either side. So you're asked in this problem to find g prime of 3. Well, g prime of 3 is the derivative. And the derivative only exists if the function is continuous and if the slopes go to the same number from either side. Now notice 3 is the place where the domain splits, right? So we're going to check for continuity. Be really quick here. X approaches 3 from the left. When x approaches 3 from the left, that's 3 minus x. And when you do direct substitution, you get 0. When I check it from the right, it uses the other function. Also get 0 when I do direct substitution. And the function itself would use the bottom function, so I'm just going to write f of 3 here. So it is continuous. Now for differentiability. Now both of these are linear, so I could just look at these and tell what the slopes are, but I'm going to use the power rule just so you can see how it works. So when you're taking the derivative of a piecewise function, you can take the derivative of each piece separately. So the derivative of 3 minus x, the derivative of 3 is 0, constant multiple rule. The derivative of negative x is negative 1. And that's true when x is less than 3. The derivative of 4x minus 12, power rule, would be 4, and the derivative of negative 12 by the constant derivative of a constant rule will be 0. And that's true when x is greater than 3. Now notice I didn't put an equal to sign on this. That's because in order for the derivative to exist at 3, the numbers have to be the same from either side. And if they were the same, I would be able to put an equal to sign where it was in the original function. But if you look at the problem here, From the left, the slope is -1, and from the right, the slope is 4. That means the slopes suddenly change at that point, which means g prime of 3, sorry, I didn't mean to say f, g prime of 3 does not exist because -1 doesn't equal 4. So again, it has to be continuous. If it's continuous, you can check for differentiability. We checked for it using the H definition before, but now we can use the power rule instead and see if the slopes go to the same number from either side. Now, if this had happened to be a function instead of just a number, I would have found the slope from that side by plugging in 3 and seeing what number it gave me. So it's that whole limit as x approaches 3 from the left of g prime has to equal the limit as x approaches 3 from the right of g prime. We had that in our notes. All right.